Alright, so in this video we will be using properties of Laplace transforms to solve these Laplace transforms. And to do these problems we'll need a couple of things. We'll need our trig identities, we're going to need the chart on 7.2, and we're going to reference the properties at the top of the packet she gave us in 7.3. So we're going to start out by doing number 5 on the homework. Number 5 isn't too bad. And again, this is on the My Math Lab homework. It's going to be 5 plus e to the negative 4t. And this whole quantity is going to be squared. Now the easiest thing to do is to just expand this. So we're going to be left with 25 plus 10 e to the negative 4t plus e to the negative 8t. And again, this is just expanding this. Okay, so now we take the Laplace transform of each term. And we just basically do what we did in section 7.2, which isn't too bad. We got to reference that chart. And so we have 25. Well, this is just a constant, so it's going to be 25 over s plus 10 times, well, e to the negative 4t. This is just e to the alpha t. So we're going to get s minus alpha, double negatives gives us a plus 4, plus 1 over, and again, this is the same property as the previous, s double negative gives us 8. And that is going to be the Laplace transform of this function. Okay, so let's move on and do number 6. Okay, so number 6. Number 6 is, again, on the homework. You should get a similar problem to this. You get t e to the 4t cosine t. Now this one's a little bit more difficult. But basically what we need to realize is this follows the property of the very last property in section 7.3 at the top of the page she gives us there. It's the one that has that fancy L that stands for Laplace. T to the n ft s is equal to negative 1n dn dsn Laplace transform of the function. Well, basically what this is saying is if we have a function multiplied by a just t or t squared or t cubed, but nothing in front of that or nothing being multiplied by that too, we can split it up like this. And this is the same thing. It's just kind of making it more obvious that we factored out a t. We can take the Laplace transform of this. Well, that's not bad. That's just using the tables given in the last section. E to the 14 cosine t is following the last property there. We're going to get s minus alpha. Well, alpha is just 4 over s minus 4 squared plus beta squared, which is just 1. Okay, makes sense. Times t. Well, basically t is to the first power, right? So n is equal to 1. So looking back at that property in 7.3, we see, hey, we have to take the first derivative and multiply it by negative 1 to the first power of this. So we have negative 1 to the first power. The first derivative of the Laplace transform of this function, which is this, s minus 4 over s minus 4 squared plus 1. Okay, well I'm going to do that over here so I don't run out of room. This is a quotient rule, so that's not too bad. It's I'm gonna factor this out to make it a little bit easier later. So we're gonna get s squared minus 8s plus 16 plus 17 actually because of that plus 1. So that's low, d high. High is just 1, so it's going to remain that, minus high, s minus 4, d low. Well, d low is just 2s minus 4. 2s minus 4 times the denominator squared. So that's going to be s minus 4 squared plus 1 all squared. Okay, well I'm gonna expand this. So s squared minus 8s plus 17 minus 2s squared minus 8s minus 8s plus 16, or 32. Okay, not too bad. Yep, all makes sense. Okay, so over s minus 4 squared plus 1, all this of course squared. Well, when we distribute that negative, we're going to get negative s squared. These are going to turn positive, so we're going to be left with plus 8s. And 17 minus 32, I am pretty sure that's going to be negative 15, but let me check. 17 minus 32 is negative 15, yep. Negative 15 over s minus 4, that's going to be squared, plus 1, and all of this, of course, is squared. And that's actually going to be the Laplace transform of this function. So again, what we did is we recognized this was a property of a Laplace transform, and we used that property to solve for it. Okay, so let's go into number 7 on the homework. This one's also a little bit tricky, but not too bad. So let's go to number 7 on the homework. Okay, so number 7 is just saying t times sine squared 60. Okay, well, I think we should use this property. So 1 minus cosine 12 theta, because it's 2 theta, 2 times 6 is 12, over 2. Now this is just a trig identity, nothing too hard, just kind of manipulating the function, and now it's in a form that we can solve the Laplace transform for. Well, first thing we can do is take out the 1/2. So 1/2, and we're left with t minus t cosine 12 theta. Okay, now what? Well, the Laplace transform of t is just 1 over s squared, and that's using the chart in section 7.2. You'll get a good feeling of how to solve for these after a while. But now what we have to do is we have to use that last property of Laplace transforms again, like we did in the last problem, to solve this Laplace transform. So this minus is going to stay out in front, and we're going to get negative 1 times n d ds. N is just going to be 1 because it's t to the first, and we take the first derivative because it's t to the first. And the Laplace transform of cosine 12 theta is just s over s squared plus 144. Okay, well this is easy. Negative 1 times negative 1 is just positive 1. So we're going to be left with 1s squared plus, don't forget this 1/2 out in front, the derivative of this. Well, again, it's just a quotient rule, but it's not a bad one. So we have low d high. D high is just 1, so we can keep it the same, minus high d low over low squared. S squared plus 144 squared. And then we can simplify this to 1/2 1 over s squared plus, we're going to get a negative s squared plus 144 over s squared plus 144 squared. And that is how you do a problem similar to number 7 on the My Math Lab homework.